Hi everyone, welcome to today's learning. Today we are going to talk about an important topic in deep learning, that is cross entropy. Cross entropy is a commonly used loss function in machine learning, particularly in classification tasks. It measures the difference between the predicted probability distribution and the actual probability distribution of the target variable. Before understanding cross entropy, you should know what is entropy means. Entropy is a measure of the amount of uncertainty or randomness in a probability distribution. Consider a simple example of a coin toss where we have a 50-50 chance of getting heads or tails. The entropy of this probability distribution is 1, which means that there is one bit of entropy or one binary digit of uncertainty. If we have a biased coin that has a 75-25 chance of getting heads or tails, the entropy of this probability distribution is lower at 0.81 around because there is a less uncertainty. Entropy can be calculated as shown in the formula, where Pi is the probability of the event occurring and the sum is taken over all possible events. The logarithm is typically taken to base 2, which means that entropy is measured in bits. Let's understand cross entropy. In deep learning, cross entropy is a commonly used loss function that measures the difference between the predicted probability distribution and the true probability distribution of the target variable. It is often used in classification tasks where the target variable is a categorical variable with multiple classes. Let's consider a simple example to illustrate how the cross entropy loss function is used in deep learning. Suppose we have a binary classification problem where we want to classify images as either dogs or cats. We have a training dataset consisting of 1000 images and we want to train a neural network to predict the correct class label for each image. We can use a convolutional neural network or ANN with a softmax activation function in the output layer to make the predictions. The output of the softmax function will be probability distribution over the two classes, that is dog or cat. We will use the binary cross entropy loss function to measure the difference between the predicted probability and the true class labels. During training, we will randomly sample a batch of images from the training dataset and feed them through the neural network. The output of the neural network for each image will be a probability distribution over the two classes, which we will compare to the true class label using the binary cross entropy loss function. The formula for calculating cross entropy is as shown in the slide. As we can see, the first equation shown, that is h of pq is equal to minus sum of x in xp of x into logarithm of q of x, which is equation for calculating the cross entropy. The equation which is shown in below is actually used for calculating the loss function. When the target variable can take on only two values, for example 0 or 1, let y be the true label and y hat be the predicted probability of the positive class. The binary class function is defined as shown in the slide. The term y into logarithm of y hat measures the loss when the true label is 1, and the term 1 minus y into logarithm of 1 minus y hat measures the loss when the true label is 0. The goal of the loss function is to minimize the difference between the predicted probability y hat and the true label y. By minimizing the cross entropy loss function, the neural network learns to make more accurate predictions on the training data and hopefully on new unseen data as well. That's all for today. Thank you for watching the video.